Hello everyone, welcome to the YouTube channel Usha Physics Online Class. And guys, today in this video we are going to discuss something very important for our upcoming CSR Net Physics exam. So guys, this video is going to be in series, that is Target 20, which is a series in which I am mainly going to provide you the videos for your upcoming CSR Net Physics exam, which is December 2020. So guys, now if I am going to talk about the discussion we are going to do in this video, so that is the discussion about the quantum mechanics basics points, most important topic which every student need to prepare. Now what are these topics and how these topics will help us to score good marks. So guys, whenever we start the preparation for any exam, so the every important thing in the initial stage is going to be know about the most important topics, okay, which can help us most of the topics to solve most of the questions in the exam. That's why I'm going to make this video and going to provide you the about the topics, an idea about the topic which are going to very important done. And mainly from quantum mechanics there are some basics we are discussing in this video. Last previous class I am discussing quantum mechanics, why its names called quantum mechanics and quantum physics. In this video we are discussing quantum mechanics basics. There are 5 basics are very important in quantum mechanics. They are discrete state of quantum system and superposition principle and Schrodinger cat. And then next one is the wave function of a particle, and then fifth one is the taking averages. In quantum physics, a quantum state is a mathematically that provides a probability distribution for the outcomes of each possible measurement and a system. That is, a mixture of quantum states is again a quantum state. Quantum states that cannot be written as a mixture of other states are called pure quantum states, while all other states are called mixed quantum states. A pure quantum states can be represented by a array in a ray in Hilbert space over the complex numbers, while mixed states represented by a density matrix. Pure states are also known as state vectors or wave functions. A new word to remember: ket. Ket it was discovered by Paul Dirac that in the year 1902 to 1984. Also called ket also called a vector sometimes. We'll see why in a later lecture. For a system with two states, you can call it two kets, that is ket 0 and ket 1. For example, when dealing with an energy spectrum of the electron in a hydrogen atom, the relevant state vectors are identified by the principal quantum number n, and then angular quantum number L, and the magnetic quantum number m, and spin jet components Sz. For another example, if the spin of an electron is measured in a dielectric example with a Stern-Gerlach experiment, this one is a Stern-Gerlach experiment. There are two possible results, that is up and down. In 1922, Stern and Gerlach sent a beam of silver atoms through an inhomogeneous beam field and dielected their positions on a screen behind the magnet. That is, results is amazing result. The beam is split into bunches. In 1922, it is the birth of the spin. A pure state here is represented by a two dim complex vectors, that is alpha and beta, with a length of 1, that is with 1. There it is. Mod alpha square plus beta square equals to 1. The singlet state of satisfies the probability property that if the particle spins are measured along the same direction, then either the spin of the first one is observed up and the spin of the second particle is observed down, and the second one is up and then first one is observed down, both possibilities occurring with equal probabilities. That is the superposition principle. That is, it exemplifies the quantum mechanic engagements. It is sin equals to 1 by root 2 into ket up and ket down minus ket down and ket up. It was represent the singlet state satisfies the property that if the particle spins are measured along the same direction, then either the spin up and spin down. which involves a superposition, a joint spin state for two particles with spin 1 by 2. And then we are going to the Schrodinger's cat. In simple terms, Schrodinger stated that if you place a cat, something that could kill the cat, that is a radioactive, and in a box and sealed it, you would not know if the cat was dead or alive until you opened the box. So that until the box was opened, the cat was in sense both dead and alive. It was represented by the Schrodinger equation. Just like this, these pictures are show you the what involves formula in Schrodinger's forms. Just like I'll see you. I show you that it is the Schrodinger cat equation. That is, whenever the cat 0 equals cat is alive. Whenever the cat 1, it means cat is dead. It shows the Schrodinger's equations, Schrodinger's cat formulas equations. And then we are going to the wave function of a particle. Wave function in a quantum mechanics variable quantity that mathematically describes the wave characteristic of a particle. The value of the wave function of the particle at a given point of space and time is related to the likelihood of the particle is being there at the time. That is, the continuous electron in one dimensional, psi equals to sigma n g m0 by half psi xn, and ket xn equals to psi wave function equals to integral dx into psi of x into ket x. Pi x is called the wave function of the electron. In the real world, the electron can be at an infinite number of positions x. The position kets are known ket x, where x takes continuous range of values. That's like probability densities rho x equals to del pi star x and phi x, wave phi x and psi x whole square. Rho x equals to psi star x and psi x equals to psi x whole square is called probability density. Normalization requirements is integral minus infinity to plus infinity dx rho x. I can show you the wave formation. That is just like these pictures. This picture shows the wave formation. The first picture shows the whenever the particle goes up in front and back, that there is the small wave formations are visible. It shows the kind of the wave formations. And then we discuss about the averages, taking averages. That is yes, there it is. Suppose an electron can be at an only discrete number of positions, just like x0 and x1 and so on xn. The corresponding let's are x0 and x1 and xn. Let us define this wave function as an averages. That is, the probability of electron being in a comma b is integral a to b dx into probability density rho x, and then average position of electron is x equals to integral minus infinity to plus infinity dx into x into probability density rho x, and average squared position of the electron is x square equals to minus infinity to plus infinity dx x square rho x. It was this lecture of the basics of the quantum mechanics. Thanks for watching. Subscribe for learning and share for helping.